All right, guys, we're here to finish up our stuff about combinations and permutations. We're focusing specifically on permutations today, and then we're going to decide on some of these later ones. Which one is it that we're talking about? Okay, a permutation or a combination. Now, combination doesn't care about order. So right here it says there are 12 people in the chess club. You need to make a committee of 3 people to help in the fundraiser. How many different committees can be chosen? So that means we have 12 people. And we have 3 committee members. So we do 12. And then how many people would be left to pick the next spot? 11. And then how many people would be picked to pick the next spot? 10. So we've got those. But remember, those 3 committee members can be organized in any way, and we don't care what order they were picked in. So then we need to divide to get rid of the repeats, or the same 3 people are showing up in those front seats. Okay, so you divide by 3 factorial. This is where I'm going to bring in the handy dandy calculator. So I would do 12 times 11 times 10. And we're going to divide that by 3. If you push math and go over to probability, do you see it? I see it. Factorial. And we get 220. So there are 220 ways to pick 3 members for a committee out of 12. That's cool. All right. So the next one says, how many lines are determined by 8 points if no 3 of the points are collinear? In other words, here's our thing. So how many ways, so if we're at 1 point, how many lines can I draw from that 1 point? Let's see. 1, 2, 3, 4, 5, 6, 7. So there are 7 lines I can draw from that first point. Okay. Now, let's go to our second point. So this was point 1, this is point 2, point 3, point 4, point 5, point 6, point 7, point 8. So on point 2, already I don't have to draw a line to point 1. But because that's going to be the same line. Here's 1, 2, 3, 4, 5, 6. So we're going to add 6 more to account for all the lines, all the new lines that are from point 2. All right, let's do from point 3. So from point 3, there's no point in drawing a line to 1 or a line to 2. So we can draw a line to 4, to 5, to 6, to 7, to 8. So that's 1, 2, 3, 4, 5 lines. So that's 5 more lines. All right. Let's go from 4. So from 4, there's no point in drawing a line to 3, to 2, or to 1 because those lines already exist. So we can draw the line to 5, to 6, to 7, and to 8. So that's 4 lines. Okay. So from 5, there's no point in drawing a line to anything before 5 because there's already lines to them. So from 5, the only new lines are going to be to 6, to 7, and to 8. So there's only 3 new lines. So from 6, running out of colors here. So from 6, no point in drawing lines to anything before it, but I can draw a line to 7 and to 8. There are exactly 2 new lines. And if you haven't figured it out yet, there's kind of a little bit of a pattern going on here. Just a little bit of one. And then 7, there's only 1 line, 1 new line I can draw. So I do 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. Let's do that. 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. 28. There are 28 different ways from 8 points that no 3 of the points are collinear, meaning they don't make a straight line with 3 points. There are 28 ways. And we proved it because, do you see our picture? It's a beautiful picture. It's very clear. Okay. We had to get rid of those repeated lines. That comes into all of this. Okay. Hopefully you don't have any questions yet. If you do, leave them in the comments of the discussion so you can get your points. Good points. All right, so notice that you have to get rid of the repeats, like how a line from point 1 to point 6 is the same as a line from point 6 to point 1. How can we do that? We divide by the number of objects that can repeat. Okay, and we did that up here when we did it we did it right here with Mississippi, okay? We also did it right here when we got rid of the repeated members of the committee, okay? So now here's the formal definition of combinations. Combinations is a grouping of items in which order does not matter. So you're going to have the number of items that you could possibly have. That's usually n factorial. Then you're going to divide by the number of items you don't need. This is essentially creating, so R is the number of spaces needed. So that's making sure you're canceling out all the spaces you don't need. This gets rid of repeats. So up above on the committee problem, we could have written this as 12C3. Okay. And we did all of that extra mathy stuff that they show right here with the n factorial over n minus r factorial. We did all of that just by limiting it to those 3 spots. Okay, so let's look at this. So how many combinations of 4 can you select from 25 baseball cards? So we have 25 baseball cards. So this would be written as 25C4. So we have 25 baseball cards. So we can pick 25 cards for the first card. Then 24, then 23, then 22. And then we just need to divide by the fact that we don't want those repeats. We don't want the group that has the same 4 cards in just a different order. That's the same group to us. That it doesn't make a different group. So then we're going to divide that by 4 factorial to get rid of repeats or repeated groups. Okay, so we do 25 times 24 times 23 times 22. So 25 times 24 times 23 times 22. We get a number. We're going to divide that by 4. Come on, go over to probability. No, just kidding. See, I struggle with this too. It's not just you. I want 4. Okay. And I end up getting 12,650. So there are 12,650 ways to organize 25 baseball cards into a group of 4. Okay. What about this one right here? You try it, read it, see if you can set it up, pause it if you need to, and then get back to me. Okay, so 15 people are volunteering to form a 4-person team. So we don't care what order they choose that 4-person team. We just care that they chose 4 people. So we do 15C, or for combinations, 4. So this is going to be 15 times 14 times 13 times 12 divided by the fact that we don't care the order, or 4 factorial. So we pull out our handy dandy calculator. 15 times 14 times 13 times 12. And we're just going to divide that by 4 factorial. Except if I put 4 factorial, that'd probably be a lot more helpful. So we get 1,365 ways that a group of 4 people can be chosen from those 15. That's a lot. Okay, so you guys are going to decide, is this a permutation or a combination? And then once you decide that, run it. I think this is the last thing we're doing today. Yeah, it is. All right, so right here. On a 12-question test, students must answer 6 questions of the first 8 questions. So you have to answer 6 of the first 8, and then 3 of the last 4 must be answered. How many ways can this be done? So we have 12. We must choose 6 of the first 8. So we have 8 Now, are we choosing, and does order matter? Order probably doesn't matter as much. We don't care if we answered question 5 before we answered question 3. We just cared that we answered question 5 and question 3. So I'm going to use combination, and I'm choosing 6. And then I'm going to add that to, so I have to choose 3 in the last 4, so there are going to be 4 questions, and I'm choosing 3. We're going to multiply those 2 options together. Because for every option here, we can pick one of these options here, so then that's going to be a problem of multiplication. All right, so we're going to do 8, choose 6. So this is going to be 8 times 7 times 6 times 5 times 4. 1, 2, 3, 4, 5, 6. There's 6 options, and then we're going to divide by 6 factorial. Cool. All right. And then this next one, we're going to do 4 times 3 times 2 divided by 3 factorial. And we're going to multiply these 2 options together. So we're going to do 8 times 7 times 6 times 5 times 4 times 3 divided by, oh, no, wait. Just kidding. Actually, I can't do this. 6. And then I'm going to go to math. Go to probability. Go to the factorial thing and hit enter. And I get 28. So there are 28 options to answer the first half of the test. And then the second, well, it's more than a half, but we would do 4 times 3 times 2 divided by 3 factorial. And we get 4. So we do 28 times 4 in our handy dandy little calculator. We get 112. So there are 112 ways to answer this test and fulfill the requirements of the number of questions answered. Interesting. I like that. All right. How many different 9-playing batting orders can be chosen from a team of 14? Here, does order matter? Yes, because it matters who goes first out of those 9. So we're going to do 14 P9. Okay, so you would do 14 times 13 times 12 times 11 times 10. Let's see, 1, 2, 3, 4, 5 times 9 times 8. 1, 2, 3, 4, 5, 6, 7. 7, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. There's my 9 ways. So I'm going to do 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6. Holy shoot, that's a lot of different ways. So 7, 6, 7, 2, 6, 4, 8, 5. 7, 2, 6, 4, 8, 5. 7, 6, 0. That's a whole lot of ways those 9 people can be chosen. All right. That's as much as we're doing today. Please go do the learning activity. I love you. I care about you. Bye.